All right, Math 30-1, it's time for us to put all this together. So, Lesson 8, where all our work comes together, and we talked about all these transformations over the time and the different ways and blah, blah, blah. So now we're combining. And don't forget, our rule is going to be SRT, stretches, reflections, then transformations. Um, you can start by sketching the original and then following through with each of those type of transformations, and you will end up with the correct transformed graph. So in the first question, what are these numbers? Take note that because we know that these things work opposite to the way they are, there's a standard that says, well, if A, F, B, x minus h plus k is the way we state the equation, what are the values of A, B, h, and k? Well, A is 2, B is a half, don't forget factor, right? Look at how they write it, factored form. A is 2, B is a half, H is minus 5 because you see a positive and it starts off as minus h, right? And k is minus 8 because what you see is what you get. If we write the transformations associated with these changes, they are a vertical stretch by 2, a horizontal stretch by a factor of 2, a horizontal translation 5 left, and a vertical translation 8 down. Now if we're going to do this to f at x, what order should it be in? Well, it should be in the order above because we always do stretches first. There are no reflections, there's none, but then we do our vertical and horizontal translations. So there is our S, no R, but we thought about it, and T. So as we complete this, we'll start by doing our vertical and horizontal stretches on this graph right here. So let's do 1, 2, 3, 4. Let's start off with, hey, a vertical stretch by 2. So this point goes here and this point went up. So there's my vertical stretch by 2. That's 1. Then I horizontally stretch that by 2. So that point is now here. And this point is here. And this is an invariant point. So there's 2. Yay. So now we're done two things. We're done our stretches. Now we do our translations. And I think I'm just going to do all that at one time. I'm going to move everything over. And one way to do this is we call it an imaginary axis. And I just say, if I want to move everything over 5 left and 8 down, why don't I just pretend that this is my crosshairs right now. I'm just going to make some new crosshairs and say everything is going 5 left and, oopsie, everything is going 5 left, so I draw an imaginary axis like that, and everything is going 8 down, so I draw those crosshairs there, and now I just redraw those points. 0, 0, go over 2, and up 2, and over 2, and up 2, based on these points right here, and I redraw those points, and there is my new graph, which has all the transformations 1, 2, 3, and 4. And that we'll call number 4 right there. And we should also label those, okay? You're going to find your own way. A student like Mackenzie might say, I'm going to do all these in one step. Whereas another student might like the crosshairs. How you do these, you can do 4 steps, is up to you. It's a matter of you making your own way with getting these done, okay? When we look at the next graph, we want to actually write the equation of this function with all those transformations, so with those substitutions. All right, so as you complete the substitutions in there, you should end up with an equation that looks like y equals 1/2 x plus 5 squared plus 8 as you complete all the substitutions. And now you could graph your graphing calculator. That's always a backup plan to see whether what you transformed actually works with what you thought the equation should work out to be. All right? Okay, as we complete number 2, ponder what the transformations are first, obviously. So if we lean on our work from before. I know that this was vertically stretched by 2. I know it was reflected in the x-axis, and I know it should go right 3 and up 1. So I'm going to approach this one just a wee bit differently. When I look at that minus 2, we can handle 1 and 2 together in one step. So I'm going to do these two together in one step. I'm going to vertically stretch by 2 and reflect an x, because really what that minus 2 does is multiply all the y values by minus 2. So this is a 5. If I multiply 5 by minus 2, that's going to be minus 10. So that point right there is going to be 5, 6, 7, 8, 9, 10. It's going to be down there. This point right here is 0. That point doesn't change. This point is 4. This point right here will become minus 8. So that point will be right there. This point doesn't change, and this is minus 2, so that will become positive 4. And so now if we connect this graph, we end up with a picture that looks like this. Okay, so this, keep in mind, this is the graph of 1 and 2 done. So it's the stretch and reflection done. And now I simply have to move right 3 and up 1. So to protect my head from getting too overwhelmed, I'm just going to draw crosshairs. 1, 2, 3, and up 1. So there's my new crosshairs. So the way I see the green graph, I will now redraw it over here. Or I guess what you could do, and maybe that's easier, is just move every one of those critical points over up 1 and right 3. So if I took this point, up 1 and 1, 2, 3, and this point, up 1, 1, 2, 3, up 1, 1, 2, 3. So the next point, and I'm just following through with each of the points over, up 1, and 1, 2, 3. So this one, up 1 and 1, 2, 3. So there's the next one, and up 1 and over 1, 2, 3. And I'll end up connecting the dots. And then this one down here, up 1 and over 1, 2, 3. Well, let's see if we can connect these dots without screwing this up. And that whole graph has been moved over to the right. And this is everything all together, number 3, with everything done. Okay? And whether you use the crosshair method or just moving it over is really up to you. Okay? Example number 3. Okay. In example 3, we're just taking transformation, writing the replacements, and coming up with an equation. So in this example, the horizontal stretch occurs by x being replaced with 4x, and the vertical translation becomes by replacing y with y plus 5, giving you an equation of y plus 5 equals 4x and y equals f at 4x minus 5. In B, if you had a vertical stretch by 3/5, how would that happen? That would happen by replacing y with 5/3 y, and the reflection in the in the y-axis would happen by replacing x with minus x, and a horizontal translation of 2 left would be replacing x with x plus 2. What would the function look like with these things done? Well, one version would be y equals 3/5 f at, now don't forget, negative, because it's got to be on the outside of brackets, always factor x plus 2 bracket. Okay, so we really need to be careful how we express that. We wrote a note and we're going to write it again. Okay, carrying on to the next question. I start with y equals x cubed, and we're forming this new function, and it tells me that I need to stretch it vertically by 0.25. One might also think of that as a quarter. So if I'm doing that, my replacement's going to have to be y getting replaced with 4y. Also, if I'm going to reflect it in the y-axis, well, then I better replace x with minus x, and if I'm going to move this thing 3 right, I better replace x with x minus 3. And again, you really have to be careful how you put this all together, because if you kind of go step by step, maybe that's the way we should do it, this replacement is going to look like 4y equals x cubed. When you add in the next one, you're going to get 4y is equal to minus x cubed, which one could solve, and you could get, I'm just going to put an arrow, you could rewrite this as y equals minus 1/4 x cubed. Lastly, you could rewrite this, sorry, as you change x to x minus 3, you're going to end up with y equals minus 1/4 bracket x minus 3 cubed. Okay, I didn't want to over-explain this, but I just, on the side here, I went, or I wanted to remind you, if we just look at function notation, okay, if we just look at function notation and we ponder what we said over here, really this is saying there should be a quarter on the outside of f, and then f at minus x minus 3. And you might say, well, I don't like the way this looks, because when we did it this way, you have a negative on the outside, and I thought that the negative should be on the inside. But when you look at the algebra, certain functions, when you simplify them, and if you took this and you did the cube, you'll end up y equals 1/4, and minus 1 cubed is simply minus 1, and then you have that x minus 3 cubed. So there are different ways that the transformation is going to occur, and it still is the same result, but they might look different, okay? All right, when we look at the next function once again, the hint comes up again. Factor out b or I will be wrong. And they gave you a hint here. So when it says to, hey, transform this function right here so that you can do it on the graph, the first thing you have to do is factor out the half, which you may not like. But dividing out a half is like multiplying by 2. So you end up with y equals f at 1/2 x plus 6 minus 8. What does it do to that graph? It horizontally stretches it by a factor of 2, and then it goes left 6 and 8 down. So I would like you to carry that stretch out and come back and see whether you have it correct. So as you can see on the green graph, I have horizontally stretched it by a factor of 2 about the y-axis, and now I move everything left 6 and 8 down. So as I moved everything over, left 6 and down 8, I end up with the blue graph there. And to finish it all off, that factoring rears its head again. So if you don't factor out, you will be wrong. G at x is equal to minus 2 square root of 3 bracket x minus 4 plus 5. So the function has been transformed by stretching horizontally about the y-axis by a factor of 1/3, stretching vertically about the x-axis by a factor of 2, reflecting in the x-axis and translating 5 units up. And here's where people would normally say 12, and they would have to cry. But we're smarter than that, because we've learned that we have to factor that out, and we're going to say that it's 4 units horizontally to the right. And they're going to get tricky, hopefully, in your assignments, and they're actually going to have negatives. Okay, so be really careful, and we're going to talk about this as we do our work on Monday.